All right, today we're tackling a big one, a threat every single pilot has to master: piston engine icing. And here's the kicker: it's not just a cold weather problem, not by a long shot.
So let's just jump right in with the question that trips up so many new pilots. How in the world can your engine ice up on a warm day? It doesn't seem to make sense, right? But understanding the physics here is absolutely key to keeping yourself safe in the air.
And that's exactly what we're going to do. Think of this as turning your textbook into the perfect set of study notes. We're going to break this whole topic down, piece by piece, so you have a clear, actionable guide to absolutely ace that exam.
Okay, first things first. Any great set of notes has to start with the main idea, right? The thesis. And of course, the key vocabulary. I mean, if you don't know the language, you can't follow the story.
This right here, this is the central truth of this whole lesson. The big takeaway is that high humidity, not just cold air, is the real danger. That means pretty much any piston engine can be at risk if the conditions are right. You've got to get that concept locked in.
So, how does this actually happen? Well, inside your engine's carburetor, there's this narrow throat. It's called a venturi. And as air gets squeezed through it, the pressure plummets. And when pressure drops, guess what? So does the temperature. It's just a basic law of physics playing out right inside your engine.
And that leads us straight to the main villain of this story: refrigeration icing. This is the stuff that can get you on a warm day. You've got the Venturi effect cooling the air, and then the fuel vaporizing chills it down even more. And if there's enough humidity, boom, it freezes solid right inside your carburetor.
Now, the second type is a little more what you'd expect. It's called impact icing. This is just super cooled water droplets smacking into a cold surface, like your air filter or the engine intake, and freezing right on contact. This is the kind of icing most people picture, you know? And finally, we have fuel icing. Now, this one's less common, and it's all about water contamination inside the fuel. When that fuel gets cold, any water in there can freeze up and start clogging the fuel lines. It's yet another reason why that pre-flight check is so important.
Okay, so we've got the vocab down. Now let's see how it all fits together in the real world. We're going to deconstruct the data and go over the emergency procedures that you absolutely must know. Okay, this chart right here is pure gold. For your exams, for your actual flying, everything. Take a look. You've got temperature along the bottom and dew point up the side. The whole game is about the spread between those two numbers. The closer they get, the higher the humidity and the bigger the risk. And just look at that red, serious icing zone. It goes all the way up to plus 20 degrees Celsius. That's a warm day.
And this diagram shows us exactly where the trouble starts. See? The air flows in, gets squeezed and cooled in that venturi, and that's where the icing kicks off. But look where it really builds up, right on the throttle butterfly valve. This is literally how the engine gets slowly and silently choked of air. So what do you do if you suspect this is happening? The procedure's simple, but I'm telling you, it can be really unnerving. First, carb heat to fully hot. Second, you wait. And this is the hardest part, because as that ice melts, your engine's going to start swallowing water. It'll run rougher, you might even lose more power for a moment. But you cannot be tempted to turn that heat off. You wait. You wait until that engine is running smoothly again.
All right, so we've got the theory and the emergency checklist down. Now let's get to the good stuff. Those aha moments, the pro tips that really make this stuff stick in your brain, especially when you're under pressure. I want you to burn this slide into your memory, especially if you're flying with a fixed pitch prop. If you see a slow, gradual, unexplained drop in RPM, your brain needs to immediately scream carb ice, and your only immediate action is to pull on full carb heat. That's it. Memorize that cause and effect. It could save your life.
15%. What's that all about? Well, that's roughly how much power you can expect to lose when you apply carb heat. And why is that? It's because you're feeding the engine hot air, which is less dense. It's a totally normal trade-off. Knowing to expect that power drop will stop you from panicking and second-guessing yourself. And here we have an absolute 100% non-negotiable rule. Under no circumstances do you use carb heat during takeoff, period. Takeoff is when you need every single ounce of power you can get. Using carb heat robs you of about 15% of that power right when you need it most. Plus, it's using unfiltered air. It's just a massive safety hazard. Don't do it. You know, to really make this stuff stick, sometimes you just gotta draw it out. So let's sketch the two most important visuals here. If you've got a pen and paper handy, grab them. A quick little sketch can lock this in your memory way better than just reading it over and over. Okay, first step, that icing chart. Don't worry, you don't have to be an artist. Just draw a big L for your axes, label the bottom one temperature, and the side one dew point. Now, the important part, sketch in that big arching curve for the serious icing zone. The key takeaway here is that the highest risk isn't actually at freezing. It's in those warmer temps when the humidity is sky high. All right, next up, the carburetor itself. Just draw a simple bent tube. Now, pinch the middle of it. That's your venturi. Just label it. Then, right after that tight spot, draw a little flap. That's your throttle valve. And that's it. That's your mental model. That's where the ice forms and chokes off your air.
Okay, we've covered the theory, the procedures, and you've even got your own sketches. Now it's time to check if it all sunk in. Let's do a quick retention check with a couple of questions you are very, very likely to see on an exam. Question number 1. You're flying along, everything seems fine, but you notice something's just a little off with the engine. What is that first primary sign that you might be dealing with carb icing? And the answer is that gradual, creeping, unexplained drop in your engine RPM. It's not a sudden lurch. It's sneaky. The ice is just slowly building up, strangling the airflow, causing those RPMs to slowly fall. All right, last question. This one is a big-time safety rule. There is one specific phase of flight where using carb heat is an absolute no-go. What is it? Yep, you got it. During takeoff. You just cannot afford to rob the engine of precious power when you need it the absolute most. Look, mastering this stuff isn't just about passing a test, right? It's about being a smarter, safer pilot. Which really makes you wonder, what other simple topics have these kinds of dangers hiding just below the surface?